Welcome friends to my YouTube channel. On my last lecture, I have told about the motion of liquids, that is streamline and turbulent motion, and I also introduced the critical velocity and a constant called Reynolds number. Now in today's lecture, I shall going to discuss an important issue, that is Poiseuille's equation. Poiseuille's equation. This is very important in order to understand the streamline motion, that is it involves the streamline flow of liquid. Okay, now in order to understand this equation, let us first we have to understand few assumption. Okay, the first assumption is that the liquid must flows in streamline motion. Okay, the liquid must flow in streamline motion. Okay, that means magnitude of velocity and direction is same at every point on its path, that is it follows a definite path. Okay, and the second assumption is that the tube through which liquid flows must be horizontal. Okay, that means only horizontal tube is allowed. Okay, horizontal tube is allowed, vertical tube is not allowed. Okay, the liquid flows in streamline motion and the tube through which the liquid flows must be horizontal. Next assumption is that the liquid layer in contact with the surface of the tube at rest. That means if this is a tube, this is the axis, the upper surface, this is at rest. Okay, and as we move along the axis, the velocity increases and maximum at the axis. Okay, the main thing is that the velocity of the liquid layer along the axis is maximum, and as we move away from axis, the velocity decreases, and that's why the upper layer is at rest. Okay, the upper layer is at rest. Okay, velocity or you can say the layer in contact with the surface, in contact with the surface is at rest, and velocity increases as we move along the axis and becomes maximum at the axis. Okay, so these are the few assumptions. Okay, at first the liquid flows in streamline motion, then the tube through which the liquid flows must be horizontal, and the liquid layer in contact with the surface of the tube is at rest, and the velocity of the layer increases as we move towards axis or as we go along the axis and becomes maximum at the axis. Okay, so these are the few assumptions which we use while discuss the Poiseuille's equation for streamline flow of liquid. Okay, okay, now if we just draw the diagram. Okay. 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 So here we see that this is a cylinder. Okay. Say this is a cylinder of, say, radius r and length L. Okay. This is a cylinder of radius r and length L. That means this is r. Okay. Fine. And this length is L. Now suppose that the pressure difference between the two ends of the cylinder is P. Okay. P represents the pressure difference between two ends. Okay. Fine. Now here we draw two coaxial cylinders inside the main cylinder. Okay. Suppose the inner coaxial cylinder is of radius x and the outer coaxial cylinder is of radius x and x plus dx. Okay. So we draw two concentric inner cylinders of radius x and x plus dx. So obviously a viscous force acts, okay, on the liquid, and due to this viscous force the motion of the liquid will be retarded. Okay, so we take two concentric cylinders of radius x and x plus dx. Okay, so motion of the liquid will be slow down due to viscous force. Okay, fine. Now at first we have to find out the viscous force. So what would be the viscous force? Here the viscous force is, there is a minus sign which indicates that the viscous force acts in the opposite direction of the flow of liquid, minus eta into area. So what would be the area of a cylinder of radius x and length L? 2 pi xl. Okay, and the velocity gradient is dv dx. This is the velocity gradient. Okay, because the motion of the liquid will be slowed down by the viscous force on the surface of the cylinder, and whenever we are considering these two inner concentric cylinders, that is of radius x and x plus dx, the viscous force is this, minus eta into area. The area of a cylinder of radius x and length L is this, and the velocity gradient is dv dx. Okay, now this is the viscous force. Now since there is a pressure difference between the two ends, and due to this pressure difference a force always acts. Okay, so what will be the force due to pressure difference? Force due to pressure difference, that means area multiplied by pressure, that is pressure multiplied by area. Now here we consider the cross section area, this. So the cross section of a cylinder is a circle, so the area will be pi x squared, because the flow of liquid is along the axis, no radial flow takes place. There is no radial flow, the flow is along the axis. Okay, so whenever there is a flow along the axis, we have to take the cross section area. So the cross section of a cylinder is a circle. That's why the force due to pressure difference is pressure multiplied by area. Okay. Now under equilibrium condition, we know that both the forces are equal. So we have to make these two forces equal. Okay. We have to make these two forces equal. So that is under equilibrium P into pi x square. This is minus eta 2 pi xl dv dx. Okay. Pi x into dx, this equals to minus eta into L by P dv. X dx, this equals to minus 2 eta L by P into dv. So if we integrate this expression, what we get? X square by 2. This is simply minus 2 eta L by P into V plus some constancy C. Now we know the boundary condition that the liquid layer in contact with the surface of the tube is at rest. This is at rest. So at x, if we take x equal to r, then that layer possesses V equal to 0. Okay. So this is the boundary condition which is in our hand, that at x equals to r, V is 0. So if we put, then we get C is r square by 2. So what will be the, if we rearrange this, so what we get into P, this equals to r square minus x square by 2. So what is V? V is this, P upon 4 eta L into r square minus x square. So this is the expression of V. Now this value of V represents the velocity of any layer at a distance x from the axis. This is the common axis. If we, so the distance x is this. So this is the velocity of any layer at a distance. That means at this layer. Okay. Fine. Now we have to find out the rate of flow of liquid through the entire cylinder. So in order to find out that, at first we have to find out the rate of flow of liquid through this elementary area, okay, between the two concentric cylinders. If we find it, then after doing integration within 0 to r, we can get the result for the entire cylinder. So what will be the volume of the liquid flowing out per unit time between these two annular areas, between this annular area? Okay, if we call it dv, then it will be area multiplied by velocity. Area multiplied by velocity, that is per unit time, that's why is this. So what will be the area of the annular area between the cylinders of radius x and x plus dx? That we all know, 2 pi x dx, because this pi into x minus dx square minus pi x square, if you do it, the result is 2 pi x dx. Fine, that's why I write it once. So what will be my velocity? This. So 2 pi x dx. If we put the value of v, that is p by 4 eta L into r square minus x square, so what we get? Pi p by 2 eta L x into r square minus x square dx. Okay. So this is the volume of the liquid flowing out per unit time through the annular zone between the concentric cylinders. Okay, and since we can divide the entire cylinder of radius r into large number of small cylinders, okay, so if we do integration within the limits 0 to r, then we will get the volume of the liquid flowing out per second through the whole cylinder. Okay, that is pi p by 2 eta L x r square minus x square dx. So let us do what the result comes. Let us see. Okay, Dear guys, if you like this video, then kindly like and share it to your friends, and also subscribe my channel. Okay, so V, this is simply pi p upon 2 eta L. Okay, fine. This is r square constant, and if we do x dx, this is simply x square by 2, and x cube dx, x to the power 4 by 4, the entire limit is 0 to r. So pi p upon 2 eta L, this is r to the power 4 by 2 minus r to the power 4 by 4. So this is r to the power 4 by 4. That means pi p r to the power 4, and there is 4 multiplied by 2, 8. Okay. So this is the well-known Poiseuille's equation for the flow of viscous liquids. Okay. Pi p, so it depends upon the pressure difference between the two ends of the tube and the coefficient of viscosity and the size of the tube, or you can say the radius of the tube. Okay. So in today's lecture, I shall discuss the streamline motion, Poiseuille's equation for the flow of viscous liquids. Okay. In our next class, we shall discuss, that is, though the liquid here flows in streamline motion, but there are some acceleration, due to which there is a correction of this law. Okay, though there is the liquid flows in streamline motion, there is some acceleration, okay, of the liquid, due to which the formula will change. That means a correction is required. We will discuss it in our next class. Okay, so today is up to this. Thank you.